All right, video 2 for 11.3. The first thing we're going to talk about are geometric properties of the cross product. So let u and v be non-zero vectors in space, so they're not just a dot, and let theta be the angle between them. U cross v is orthogonal both to u and v, so that's what we did in example 1. The magnitude of the cross product is the same as the magnitudes of u and v times the sine of the angle between u and v. So we could use that if we wanted to, instead of calculating the cross product. U cross v is 0 if and only if u and v are scalar multiples of each other. Okay, so if you get the cross product as 0, it's really the same vector, just different sizes. And then this last one is one we're going to use a lot. If you do the cross product and then take the magnitude of that vector, you can find the area of a parallelogram with two adjacent sides. Don't use the sides opposite each other, but use the adjacent sides. All right, so here's our first example. We're going to find the area of this parallelogram. It has those given vertices, 520, 261, 247, and 506. And here's a picture of it. So we're going to write them first as vectors. Okay, so I'm going to find all of the vector pieces. Let me grab a pen. Okay, so I'm going to just write each side in vectors just to show that this is a parallelogram. So what I'm looking for is like these two vectors to be the same vector just in a different spot. And then what do I need? dA. Okay, so AB, remember I'm just going to do B minus A. Okay, so 2 minus 5 is -3. 6 minus 2 is 4. 1 minus 0 is 1. Okay, for BC, I'm going to do C minus B, terminal minus initial. So 2 minus 2 is 0. 4 minus 6 is -2. And 7 minus 1 is 6. All right, CZ, I'm going to do D minus C. So 5 minus 2 is 3. 0 minus 4 is -4. And 6 minus 7 is -1. And then DA, we're going to do A minus D. So 5 minus 5 is 0. 2 minus 0 is 2. And 0 minus 6 is -6. So if you look at these two vectors, AB and CD, AB, which is this side, and CD, you'll see that they are the same vector. It's just I made one point the opposite way. That's why all the signs are opposite. And then BC and DA are the same vector, just again, opposite signs. So I could make them all have the same signs and be equivalent. That's not too big of a deal. Okay. All right. So now we're going to do the cross product between two of these that are adjacent. So I'm going to pick these two. I'm going to do AB cross with BC. And then I'll just find the magnitude, and that will be the area of the parallelogram. Okay. So again, I'm going to write my matrix IJK. And then I'm going to put the vector, so -3, 4, 1, and 0, -2, 6. And then I'm going to augment the matrix by just writing the first two columns again. Okay. And now I'm just going to do my diagonal multiplication and addition. So here we go. We have 24i. Let's see, 0j, and then 6k. All right, now I'm going to do it in the opposite direction, 0k, -2i, and then -18j. Okay, now I'm going to combine, oh, you can't even see that. There you go. I'm going to combine all the like ones. So let's see, I got 2i here distributing the negative and 24i, so 26i. I got, oh, this last one. What does it even say? Oh, yeah, let me rewrite it. That one says -18j right there. A little smudgy. Okay, so -18j, but I'm going to make it positive and add it to nothing. And then 6k minus 0k is just 6k. Okay, so that's my cross product. And now I'm just going to find the magnitude. So the magnitude just of any vector, remember, is the square root of each piece squared and added. Oh. has been square rooted. And I'm going to run and grab my calculator. Give you time to write it down. All right, 26 squared, 676, 18 squared, 324, and then plus 36, and then I'm going to square root those, and that will be the area of this parallelogram. So about 32.2 square units. Okay, so that might be easier, especially since this is a three-dimensional parallelogram, than actually trying to find the side lengths and using a formula from geometry. Okay, so that's how to find the area of a parallelogram.